Now this is asked in your GATE 2004. It is a very good question. They are saying that two matrices, two matrices M1 and M2 are to be stored in array A and B. So you need to store two matrices M1 and M2 in array A and B. Means, see, to store a matrix, we require two-dimensional array. Okay, so we require a two-dimensional array. So A is your two-dimensional array and B is your two-dimensional array. Each array can be stored either in row measure or column measure order. So it can be stored either in row measure or column measure order. So see, row measure and column measure order is a part of your data structure. Okay. So row measure means it will store the, in row measure order, it will store the first row in the array in the memory, then second row in the memory, then the third row in the memory. Okay. And or column measure. In column measure order, it is going to store the this column. Okay. Now they are asking, see, what is row measure order? In row measure order, the row is going to be stored row wise row, first row, then second row, then third row in a contiguous memory allocation. In column measure order, first column, then second column, then third column. Like this, it will get stored. Now they are asking the time complexity of an algorithm to compute M1 and M2 will be. Now they are asking what is going to be the time complexity of M1 into M1 into M2. So they are asking based if A is a row measure order and B is a column measure order. So what is a row, in how we do the multiplication of two matrix M1 into M2? How we do? So we take the first element of this, okay, and we multiply the first element of this, then second element of the column C with third element of this with the, this means row by column it go like this. Now they are asking, if you do, option A is saying based if A is a row measure and B is a column measure, based if both is a row measure, based if both are in column measure, and D is independent of storage scheme. So many of you has given D as the correct one, and D is the correct answer. D is the correct answer. Very good. So what is the explanation why? Because independent of a storage scheme. Why I am saying it is independent of a storage scheme? Because in the, whenever we find the time complexity, we assume that to fetch any element from the memory, it take constant time. Okay. So whether it will store the row wise row or column wise column or in any order, I am going to assume that it is going to take constant time. To fetch any element from the memory, it is going to take constant time. Because in time complexity, we don't consider this thing. We assume it is a constant time. Okay. So whether it is a row measure or column measure, always it is going to take constant time. Okay. That's our assumption. Actually, it is not going to take constant time. Okay. Is it clear? So it is independent of a storage scheme. So whenever they are asking you to find the time complexity, you always assume that to fetch any element from the memory, it is going to take constant time only. So how you are doing the storage, it is not going to affect. Okay, but that will affect in your implementation. If you do the implementation, if you do the, see, this is they are finding the time complexity. Now if you implement that, then which is going to be the answer? Now if you implement that, if I'll change the question, if I'll ask you that if you implement this, then what is going to be? Yogita, is it clear? Himanshu, please let me know whether it is clear or not. See, if you do M1, if you store M1 in row measure and then M2 in column measure, then it is going to be your useful. But in considering the time complexity, we are not considering the storage scheme. We are not considering the storage scheme, how we are storing. Okay. But now if I change the question, if I'll ask you the, which is good for the, implementation, then what is going to be the answer? Now tell me. Now I'm not asking you the time complexity, I'm asking you which is going to be the most efficient for the implementation. If I'll ask you to implement that in your system, then which is going to be correct answer? Shweta? Now if I'll ask you the implementation, then A is going to be the correct one, because then you need to consider after in implementation, actually the time complexity will be less when A is in row measure order, because you, for matrix M1 you require you require the row, and for M2 you require the column. Okay, because first you will use this row, then you will see first row, when you multiply with this column, then you are going to get this element. Then first row, if you multiply with this element in this column, then you are going to get this element. Then third time, when you again multiply with this third column, then you are going to get this element. Okay, this add 2, add 3. Then you will take the second row from M1. Then again you will take the first column, then second column, then third column, like this. So in implementation you require a row measure storing of this. Row measure means you want to store the first row, then second row, then third row, and here you want to store that first column, then second column, then third column, because here you are fetching the element in column wise, here you are fetching the element in row wise. Are you getting that? If I'll change as a implementation, then A is going to be your correct one.